in this video, we're breaking down the anatomy of the ear, from the visible structures that you can see and touch to the tiny bones and membranes that help you hear the world around you. So we'll look at how sound waves travel through the ear, how each part plays its role in hearing, and explore some of the anatomical names for different parts of the ear. So this is the external ear, also known as the pinna or auricle, meaning ear. It's made up of flexible cartilage, and from an evolutionary perspective, this shape kind of gave mammals an advantage for improving sound localization and amplifying frequencies for communication and survival. The blood supply is divided into the anterior part, which is the superficial temporal artery, which comes from up here, while the posterior ear is supplied by the posterior auricular artery, so behind the auricle. So the external auditory canal is about 2.5 centimeters long and slightly S-shaped, and it channels sound towards the eardrum. So this main outer part of the ear is called the helix. And inside that helix, kind of little fold, is the scapha or scapha, but this part's the antihelix. It's the helix and the antihelix, but in here it's the triangular fossa, kind of little pouch inside, and in there it's the concha, meaning shell, basically, just the inner kind of groove and where the cimber is. But this is the tragus and the antitragus, and in between you can get the intertrageal notch, or I think it's spelt tragic notch, but down here is the lobule, which is where you can get ear piercings, or a lot of people get ear piercings from. So in here is the external auditory meatus. The tragus is where, when children kind of put their hands in the ears, that kind of flap of skin completely covers up the external auditory meatus, so it cuts out all sound. So if we open up our ear model, we can see the ear canal, where sound and sound waves are directed towards the eardrum. You might notice quite a lot of tiny hairs on and around your ear, particularly at the entrance to the canal. So these velous hairs and thicker terminal hairs help trap dust and debris, and just your skin kind of shredding, and it gets pushed out, and that's how wax can form. And it can sometimes form right on this tympanic membrane. So this tympanic membrane, or eardrum, also known as, so when sound hits it, it vibrates, which converts air pressure into mechanical energy. So these vibrations are then passed to the three tiny bones of the middle ear. So those are called the ossicles. So this is where the smallest bone in the body is, right in the middle ear. So the tympanic membrane has a conical shape with the tip pointing inwards. This helps transmit vibrations efficiently to the ossicles, which are the small bones of the ear, the smallest one in the body. On inspection, you'll often see the cone of light, the handle of the malleus, and sometimes even the pars flaccida and the pars tensor as well. So damage to this, or dullness, or perforations, can significantly impact your hearing. So that's the malleus right there, leaning on the tympanic membrane. So if we have a quick look at the tympanic membrane, we can see the pars tensor, the thin layer, and on the outside we can see the annulus, and in the middle the umbo. And the vibrations from the TM move the ossicles, which is the malleus, which is connected to the tympanic membrane, the incus, the anvil, and also the stapes, or stirrup, which is the smallest bone in the body, which presses against the oval window of the cochlea. So these bones form a lever system, kind of, that amplifies sound about 20 times, or 20-fold, from air to fluid medium. So in the inner ear, we have the semicircular canals. We've got the anterior semicircular canal, and around the back we've got the posterior semicircular canal and the lateral semicircular canal, which form part of the vestibular system, which is responsible for your sense of balance and spatial orientation. So here we can see the cochlear nerve and the cochlea as well. So each canal is kind of filled with an endolymph that when your head rotates, the fluid lags behind, which bends hair cells inside a structure called the ampulla. So these cells convert the mechanical movement of electrical signals, which is sent via the vestibular nerve. So finally, we've got the eustachian tube, which connects the middle ear to the back of the throat to equalize pressure across the tympanic membrane. And also, we've got the tensor tympani muscle, which dampens excessive vibrations of the tympanic membrane as well. The ear is more than what we just see on the outside. It's a complex, finely tuned system that's designed to capture sound, translate it into mechanical and then electrical signals, and then send it to the brain for interpretation. The external ear funnels sound into the canal. The tympanic membrane and the ossicles amplify those vibrations, and the cochlea converts them into signals that we understand as hearing. At the same time, the semicircular canals detect the head movements that we make to help us stay balanced and upright. And in fact, the reason that you're able to follow this video right now and hearing my voice, interpreting each word, is because your auditory system is working perfectly and working in perfect synchrony as well.